cannot guarantee much in terms of the specific questions that they are going to ask you on your exams, but one thing I can 100% guarantee you on is they are going to ask you a question on modelling using differential equations, because they have asked a question on it every single year from 2018 to 2024. So it's really important that you know how to do this. This is the question they asked in the June 2019 papers here that's worth 15 marks. It's probably the most amount of marks that I have seen for a single question in an A-level maths exam. Pause the video if you want to have a go at it, and I'll go for the answer now. Okay, so for part A, we need to use the substitution u is equal to 4 minus root h to show that the integral of dh over 4 minus root h is equal to this here for 6 marks. So this is an integration by substitution question, and it's kind of one of the nicer ones because it actually gives us the substitution to use here, this u is equal to 4 minus root h. And if you look at this integral that we need to solve here, you can see that we have this 4 minus root h in the denominator. So straight away we can make a substitution and write this as the integral of dh, and then sub out this 4 minus root h denominator here for a u, like this here. So we've simplified it. So if you remember how to do integration by substitution, another thing that we need to do is get rid of this dh here for a du, and the way that we're going to do this is, if you consider the substitution u is equal to 4 minus root h, so u is equal to 4 minus, and instead of root h, if you remember your indices laws, we can write this as h to the power of a half, like this here. We're going to differentiate this, so it's going to be du over dh is equal to, so 4 is just a constant, so if you differentiate it goes away, and if we differentiate minus h to the power of a half, it's going to be minus, and then this half is going to come down as a coefficient, and then it's going to be h to the power of minus a half, like this here. We can simplify this, so we can write this as du over dh is equal to, so we have minus a half, and if you remember your laws of indices, this h to the power of minus a half, we can write this as 1 over h to the power of a half here, and therefore du over dh, we can write this as minus 1 over 2, and then h to the power of a half, but we can write this as root h, like this here. Okay, now we need to make dh the subject here, so we can sub it out. So we need to make dh here the subject, so if we multiply both sides by dh to get rid of this denominator here, so therefore it's going to be du is equal to minus 1 over 2 root h dh. If we multiply both sides by this 2 root h denominator, so it becomes 2 root h du is equal to minus dh, and if we multiply both sides by minus 1 here to get rid of this minus in front of the dh, it's going to be minus 2 root h du is equal to dh. So we've made dh the subject here. Now we have h here, this root h, this minus 2 root h. If you consider the substitution u is equal to 4 minus root h, if we move this 4 to the other side, so it becomes u minus 4 is equal to minus root h. Now here we have minus 2 root h. If we multiply both sides by 2 here, so we get 2u minus 8 is equal to minus 2 root h. We can sub out this minus 2 root h here for this 2u minus 8. So we can write this as 2u minus 8 du is equal to dh. And we can sub this out for dh, so we can write this here as the integral. Rather than dh, we can write this as 2u minus 8. I'm going to write the du down here like this, and all of this is over the u, like this here. And this we can integrate because all of the terms are now u, and we've got this du here. So we can go about integrating this. So we have this fraction here. We've got 2 terms in the numerator and 1 term in the denominator. So we can split this up and write this as the integral of 2u over u minus 8 over u, and then du. So 2u over u, this u will cancel out with this u to leave us with the integral of 2, and then minus 8 over u du, like this here. Okay, so we have these 2 terms, so let's consider them individually. So if we start with integrating 2 and then du, this is going to be equal to 2u, like this here, if we integrate this. And then if we integrate this minus 8 over u, I think it's easier if you take the minus 8 out of the integral. So you write this as minus 8 and then the integral of 1 over u, like this here, and then du, and this is going to be equal to minus 8, and if you integrate 1 over u, this is year 2 integration, it's equal to the natural log of the modulus of u, like this here. So therefore these two terms integrated, if we add these two terms together, it's going to be 2u minus 8 natural log of the modulus of u, and then remember the plus c on the end. Okay, so if you look at the final answer, we don't want u in the final answer, we want this root h. So what we're going to do is we're going to sub back in this u is equal to 4 minus root h. So if we do this, it's going to be equal to 2, and then instead of u, it's going to be 4 minus root h, and then minus 8 natural log, and then the modulus, and then instead of u, it's going to be 4 minus root h, like this here, and then plus c. If you expand this bracket here, it's going to be 2 times 4, which is 8, and then 2 times minus root h, which is going to be minus 2 root h, minus 8 natural log of the modulus of 4 minus root h, and then plus c. Now if you look at the final answer here, so we have this minus 8 natural log of the modulus of 4 minus root h, which is what we have here. So this part is fine, the minus 8 natural log of the modulus of 4 minus root h. We also have minus 2 root h, so this is going to be this minus 2 root h here. What we have left over, we have this 8 and we have this plus c here, so plus 8 plus c. If you look at the final answer, it has this plus k on the end, where k is a constant. So 8 is a constant and plus c is a constant because it's the constant of integration. So therefore what we can say that k is equal to 8 plus c, and therefore we can say that minus 8 natural log of the modulus of 4 minus root h minus 2 root h, and then instead of this 8 plus c, we can write plus k, like this here, and this is the final answer that's required. Okay, so the question goes on and it says a team of scientists is studying a species of slow-growing tree, and the rate of change in height of a tree in this species is modelled by this differential equation here, where dh over dt is equal to t to the power of 0.25 4 minus root h over 20, where h is the height in meters and t is the time measured in years after the tree is planted. And for part B, for 2 marks, we need to find, according to the model, the range in heights of trees in this species. Okay, so there's a few ways that you can view this question. The way you can view it is if you think about a tree that is growing, you're trying to think about the maximum height that this tree could reach. Okay, so the tree will be growing and growing and growing until eventually it reaches its maximum height up here, and it will stop growing. If it stops growing and the height is no longer changing, this means that dh over dt is equal to 0 because the tree is no longer growing. Another way you can think about this is if you're trying to find the maximum height, remember the maximum is a stationary point, and this is where the derivative here is equal to 0. You can view it kind of either way. The point being, you need to get that dh over dt is equal to 0, okay? And as we know that dh over dt is equal to this here, we can just set this equal to 0. So we can say that t to the power of 0.25 4 minus root h over 20 is equal to 0. If we multiply both sides by 20, we get t to the power of 0.25 4 minus root h is equal to 0. Remember that t to the power of 0.25, anything to the power of something, cannot be equal to 0. So it doesn't matter what the value of t is, t to the power of 0.25 is not going to be equal to 0, so therefore we can divide by it because there's no chance that we're dividing by 0. So therefore if we divide by it, we say that 4 minus root h is equal to 0. Move the minus root h to the other side, so we get that 4 is equal to root h, and then square both sides, so we get that 16 is equal to h. So this here is the maximum height. It's 16, so remember it's h is equal to 16 and it's in meters. Just quickly, I actually think this question is slightly badly worded because it says find the range in heights of trees in this species. When it says the word range, so we know that the maximum height is 16, so we know that h is less than 16. When it says range, I'm presuming that it wants a lower range as well in terms of the minimum height that the tree could be. And as t is the time after the tree is planted, I assumed it was planted as a seed, and this would be where the height is 0. So I would give the answer as that h has to be bigger than 0 and less than 16. And this is a valid answer. They would give you the 2 marks for this. However, it actually says in part C, it actually says that one of these trees is 1 meter higher when it's first planted, which would actually suggest that the minimum height is not actually 0, it's actually 1 instead. I just think it's slightly badly worded. If you actually look at the mark scheme, it doesn't actually care if you put a minimum value or not. All it wants is that h is less than 16. The point that I just think this question should, rather than talking about range, I think the question should just be find the maximum height of the tree, which is equal to 16. Just as well, the mark scheme doesn't care about the inequality sign here, whether you give this one or this one here. They'll give you the marks either way. Okay, so the question goes on. It says one of these trees is 1 meter high when it's first planted, and according to the model for part C, we need to calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures for 7 marks. So we need to solve this differential equation here. Now, I've done 2 videos on differential equations. The first one was on solving differential equations, and the second one was using differential equations in a modeling scenario and the type of questions that they can ask you. I would really recommend, if you struggle with questions like these, to go back to those 2 videos. I think they are 2 of the best videos that I have made on this channel. So we need to solve this differential equation here. Now, as I talked about in the first video that I just referenced, there are 3 steps to solving a differential equation. Firstly, you need to rearrange it to get all of the h and dh terms onto one side of the equation and all of the t and dt terms onto the other side of the equation. Then you need to integrate both sides of the equation, and then you need to find the constant plus c. Okay, so if we do it for this example here, so for the first step, we need to rearrange to get all of the h and dh terms onto one side of the equation and all of the t and dt terms onto the other side of the equation. Let's get all of the h terms onto this side of the equation and all of the t terms onto this side of the equation. So on this side, we already have the dh. We need to get this 4 minus root h onto this side. So if we divide both sides by 4 minus root h, we get 4 minus root h under 1 dh over dt is equal to, I'm going to write this t as to the power of 0.25 over 20. I'm going to write this as 1 over 20 t to the power of 0.25. So we've got all of the h and dh terms on this side. So now we need to get this dt term onto this side. So we multiply both sides by the dt denominator. We get 4 minus root h under 1 dh is equal to 20 under 1 t to the power of 0.25 dt, like this here. So we've done the first step. So the second step is we need to integrate both sides of this equation here. So we're going to integrate this side. So it's 1 over 4 minus root h dh, and this is equal, and then we're going to integrate this side here. So it's 1 over 20 t to the power of 0.25 dt, like this here. So we need to integrate this both sides here. This side is actually part A, where we needed to integrate this here and show it's equal to this here. So therefore we can write this side here as minus 8 natural log of the modulus of 4 minus root h minus 2 root h plus k, like this here. So this is this side integrated, and this is going to be equal to this side integrated. So it's going to be 1 over 20 multiplied by, and if you integrate t to the power of 0.25, so this power is going to go up to 1.25. So we're going to divide by this power, so it's 1.25 under 1 t to the power of 1.25. We can simplify this. We still have this minus 8 natural log of the modulus of 4 minus root h minus 2 root h plus k, and this is equal to, and then 1 over 20 multiplied by 1 over 1.25 is going to be equal to 1 over 25 t to the power of 1.25. The plus c, remember, is kind of incorporated into this k here. Remember, k is equal to 8 plus c, okay? So now we need to do the third step. We need to find plus c, or technically in this case we need to find plus k. So the way that we're going to do this is we are told in the question that one of these trees is 1 meter high when it is first planted. So we're told that the tree is 1 meter high, so that means that h is equal to 1, and t is going to be equal to, so we're told this is when it's first planted, and t is the time measured in years after this tree is planted, so t is going to be equal to 0. So what we're going to do into this equation here for the third step, to find plus k, we're going to sub in h is equal to 1, t is equal to 0. So if we do this, it's going to be minus 8 natural log, and then it's going to be the modulus of 4 minus root h, so 4 minus root 1, and then minus 2 root h, so root 1, plus k is equal to 1 over 25t, and t is 0 like this here, and this is the power of 1.25. We can simplify this, so this is going to be minus 8 natural log, and then 4 minus root 1 is 3, so this is going to be the natural log of 3. We don't need to worry about the modulus sign anymore. And then this is minus 2 root 1, so this is going to be minus 2, then this is plus k, and this is equal to, so here we have 0 to the power of 1.25, which is going to be 0, and then it's multiplied by this here. If you multiply something by 0, it's going to be equal to 0 like this here. So we need to find k, so if we just move this minus 8 natural log of 3 minus 2 onto the other side, we get that k is equal to 8 natural log of 3 plus 2, and this is the value of k. Okay, so now we know the value of k, we can write out the full differential equation as minus 8 the natural log of the modulus of 4 minus root h minus 2 root h, and then plus k, and k here is 8 natural log of 3 plus 2, and this is equal to 1 over 25 t to the power of 1.25, and this here is the differential equation solved. Now for the question, we need to calculate the time this tree would take to reach a height of 12 meters. So here h is equal to 12, and we need to find the value of t. Okay, so h is equal to 12, and we need to find what t is. So if we sub this in, it's going to be minus 8 and then the natural log of the modulus of 4 minus, and then instead of h, it's going to be root 12 like this here, minus 2 root h of root 12 plus 8 natural log of 3 plus 2, and this is equal to 25 under 1 t to the power of 1.25, and we need to find t here. If you put all of this here into your calculator, in the question it said it wants the answer to 3 significant figures. Me personally, whenever it says something like that, I always do my working in 2 more significant figures than it's asking for. So if you put all of this here into your calculator to 5 significant figures, it's equal to 8.8512, and this is going to be equal to 1 over 25 t to the power of 1.25. If you multiply both sides by 25 here to get rid of this denominator, it's going to be 221.28 is equal to t to the power of 1.25, and then if you take the 1.25 root of 221.28, if you put this into your calculator to 3 significant figures, is equal to 75.2, and then remember t is in years, so it will take 75.2 years for the tree to reach a height of 12 meters.